Alright students, I want to make a very quick video on the right triangle altitude theorem. And so what does that mean? Basically what it says is if the altitude or height is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and similar to each other. So here's an example. Here's a right triangle and I've drawn in this altitude here, and that means that all three of these triangles are similar. So triangle ABC, the entire triangle, and so I've gone along the long side, not the hypotenuse, the long leg of the large triangle and the short leg to form my triangle. So I'm going to do the same thing for the next triangle. So ADB, so this is the long leg of that triangle, and then the short leg of that triangle, of this one on the left, and then BDC, so that's the long leg and then the short leg. So those are all similar to each other, and that's the correspondence. So what we can do is we can use this to solve a lot of problems, and this is the example problem on, I believe, 7.4? I'm not sure. But anyway, this is the example problem, and we could use Pythagorean theorem here to find this missing side. But if I set up my correspondence, right, so PYT is the entire triangle, and I'm going again along the long leg and then the short leg, and PHY is this triangle on the left, and YHT is this triangle on the right. So I set up my correspondence, so this tells me all of the ratios that I need to solve for the missing pieces. So if, for example, I'm looking for the altitude here, this X, then what I can do is just say, all right, well, it's going to be PY over YT equals PH, this side, over YH, right? So I'm just focusing on these two triangles here, this one, so PY over YT equals PH over YH. So I'm not using the entire triangle, I'm just using the two triangles on the left and right. Because actually this triangle here on the left, I know two of the sides. So that's going to be the most helpful one to use. So I can set up my ratios, cross multiply, and what do I get? X equals 12. You would have found the same answer if you used Pythagorean theorem to figure out this missing side. So you could have said a squared plus b squared equals c squared, and you would have found the same thing. Now, the reason I wanted to show you the right triangle altitude theorem is because it's really cool when you think about this relationship. So the left side here of this left triangle over the altitude equals the altitude over the right. And so if we just look at our correspondence here, that all works out. So basically what that's saying is PH over YH equals YH over TH, right? Left over altitude equals altitude over right. If I cross multiply that before even putting any numbers, what do I get? I get PH times TH equals YH squared. So I can use that, or I can go ahead and cross multiply. So it's just 16 over 12 equals 12 over Z. So if I cross multiply that, what do I get? I get 16 times Z equals 12 times 12, which is 12 squared, right? So that's basically what I did here. So I could either use this one or this one. So 16Z divided by 16 is 1Z. 144 divided by 16 is 9. So let's look at one more example. If I have this triangle ABC again, with this altitude drawn to D, what this is really showing us is the geometric mean. So if I multiply two numbers together and take their square root, I get this altitude of the triangle. So what I would do is just say it's 9 over x equals x over 4, right? That's what I set up here, 9 over x equals x over 4, so it's the left over the altitude, altitude over right, 9 over x equals x over 4. Cross multiply, you get 9 times 4 equals x squared. 9 times 4 is 36 equals x squared. Take the square root of both sides, and you get x equals 6. So it's funny, I used to use geometric mean all the time when I worked in finance, because interest rate calculations are just multiplying numbers together to figure out compounding interest. And I always wondered why it was called geometric mean, and I actually looked it up many times, and nobody really had a very good answer. But I think the reason it's called geometric mean is because when you multiply two numbers together, it creates, and take the square root, it actually creates this altitude of the triangle. So I think that's why it's called geometric mean. It's a really cool relationship between these two sides here and the height of the entire right triangle. So you could try it with other numbers too. Any two numbers that you multiply together and then take the square root, it's going to form this relationship here. It's going to create a right triangle with that altitude. And it's also going to show you how to break up the hypotenuse of the entire triangle, like where to put that altitude. So a really, really cool, neat thing. Anybody that moves on to finance and interest rates, interest rate calculations, you're going to use geometric mean all the time. So I hope this helps. Please let me know if you have any questions.